this video, we are going to be talking about light, something which we all see around us. See, light is nothing but a transverse wave, which means the particles of light actually oscillate perpendicular to its propagation. Well, let's take an analogy. If the light is going from left to right, its particle will be going up and down. They are not actually traveling at the starting, but they are just propagating the energy between them to the next particle. It is a non-mechanical wave. Well, what does that mean? Non-mechanical wave basically means that it requires not any amount of medium in order to travel. Like we have the sound, in which we require what we call a medium, so that the sound's vibration can transfer from the particle to particle in order to give the impression of hearing. But now we're talking about vision, we don't require any kind of medium at all. Well, that's why the sun's heat energy, the light, is actually getting to the earth without any medium in between, because there is just vacuum and space there. Well, the light can be defined as a form of energy which is from what we call an electromagnetic spectrum, where the actual thing, or what we call the wavelength of the light that we can observe, ranges from 400 nanometers to 700. Well, 400 is the light with the least amount of energy, and 700 is the most energetic light. Well, all the colors that you see around you are nothing but what we call these wavelengths, which actually create a different impression in our eye sensors, which we call the different kinds of cells, which actually grasp what we call the color 792,458 meters per second. Yes, light can travel this much of distance in just a second. Well, many of people believe that light could wrap around the earth or the equator 9 to 10 times in a second. That's how fast the light is. Well, now let's talk about calculations. Whenever you include light in your calculations, you don't have to take this huge number or this huge 9-digit number. What you do is just round off a figure and create 3 into 10 to the power 8. That is the most unique, what we call the most popular speed of light. If you ask anyone about the speed of light, he will only going to tell you about the same thing. Well, light has a feature called a rectilinear propagation. Unlike sound, which spreads across in the medium, light always travels in a straight line. But there is a difference. See, the thing that we see whenever we actually open, what will happen if you want to make something which you call a diagram for this illustration? Well, you not have to draw the infinite amount of rays that are going to somewhere. You just have to take what we call ray is nothing but an individual arrow, or the individual particles movement across what we call the medium, or if there is a vacuum, the individual of light is known as the ray of light itself. Now let's talk about reflection and refraction are some of the most important characteristics of light. Well, reflection is defined as the bouncing back of light from the surface or the same medium and again bounced into the same medium. Well, what does that mean? I cannot understand it. See, when light is traveling in a medium A, let's say there is no medium. If you placed a mirror in a vacuum, then you will notice that the ray of light comes from one side and actually incidents with what we call the plane mirror. Well, then the plane mirror is actually able to what we call reflect that ray or that beam into some another direction, and that another direction is the same medium which we have here also. This is defined as the reflection. Well, it is nothing but the bouncing back of the light from any smooth surface. Well, how smooth? Well, have you ever touched the glass surface is extremely smooth, but whenever you take a glass sheet and put a white paper behind it, you will notice that you can see some of your image into it. That is a virtual and erect image. Well, just put something 90. You might be knowing this thing that whenever you see the reflection of yourselves, you will take the right hand up, and if you just turn it like this, he will actually get their left hand. That's the same thing which you call the Latin inversion. Well, there are many concepts regarding what we call the reflection of light. There is something called the incident ray, which is nothing but some amount of ray which is coming directly and incidenting with the mirror itself. Then we have what we call the point of incidence. Well, that's the point or the exact position of the ray and the mirror at which they are actually touching each other. There is the reflected ray, the ray which is actually reflected by the incidence or the mirror, and it is directly coming bouncing back on the mirror, and what we call reflects towards in the different mirror itself. Normal is nothing but a imaginary thing. How we just imagine equator is the same thing here also. What you do, if you take a 2D mirror, you will add a perpendicular at the point of incidence. Doing this actually gives us a reference point so that we can measure the angles of incident and the reflection. We will see that how it works. Well, the plane which actually is perpendicular to the normal is known as the normal plane. Well, it comes in uses if you want to make a 2D image. Well, the angle of incidence is nothing but the angle subtended by the normal and also the incident ray that is coming. The between part, that's the same angle which you call the angle of incidence. Well, come to this side, you will notice that the angle subtended by the normal and what we call the reflected ray is nothing but the reflection angle, or what we call the angle of reflection. See, we cannot see anything in the mirror without what we call an image or an object. Well, we are an object according to physics, and whenever we look in the mirror, we see the image of that object. Well, object can be anything, right? There mainly two types of object. First one is what we call the point object. Can be a very small object like a pen, pencil, pin, a ball, or anything which concludes a very small point. An extended image can be, well, by the way, the P object or what we call the point object is denoted by bracket dot, which means it is very small to comprehend. But talking about an extension object or the extended object, we have different examples like cars, bus, a tower, a building you might be saying. It is denoted by bracket and an arrow pointing upwards, making that extension look. Well, now let's talk about what we call the different kinds of images which are formed in those mirror. Talking about reflection, we're just talking about a plane mirror here. Well, talking about the virtual and the real image, well, see, real image is formed when two actual ray of light actually meets in between to create a sensation of vision, which we call the real image. The projectors that you see movie on are creating the real images. How? Because the light rays are actually hitting the wall, creating what we call the glimpse of the colors, which is nothing but a real image can be obtained on the screen, which virtual images cannot. See, virtual images are something which are virtual, literally, which means if you see a plane mirror, you are not seeing yourself in the mirror. You are seeing an image which actually looks like it is coming from the back of the mirror. Well, it is a very great phenomena. It looks like the mirror has another world itself. Well, that's what we call the light. You cannot imagine the world without light.